Hello everyone, welcome back to Binge's Education. And our today's topic of discussion is questions on time, speed, and distance. So we are already done with two videos on TSD. The first one in which we understood the basics of time, speed, and distance. We understood the concept of average speed. How do we calculate average speed? Then we also understood the concept of relative speed, and then based upon that, we solved a couple of questions. Right. Now, in this third video, what we'll be doing is we'll be again solving a couple of questions. So we'll be solving approximately 8 to 10 questions in this video, continuing where we left off in the previous video of time, speed, and distance. Okay. Now, if you're solving TSD for the first time, if you're GRE and GMAT aspirant, you do not know what are the basics of TSD, then I would suggest you to uh, learn from the basic videos of time speed distance, that is basics as well as questions. So you can go to YouTube and simply type binges education SAT plus GRE plus GMAT and go through the basics of time speed and distance. Okay. There are only limited concepts as far as TSD is concerned. There's not much that you expect in GRE or GMAT from this topic, but yeah, the two topics are sorry the topic time speed and distance is actually really interesting. Okay, once you start uh, using variables instead of simply using numbers, then things tends to get a bit complicated sometimes. Okay. All right, now without wasting your time any further, let's start with the next question, that is question number 10. We were done till question number 9, so this is the next question that we'll be starting off with. So pause the video and try this question before I go on to solve this question. Take your time. Okay. So if a man cycles at 10 kilometers per hour, then he arrives at a certain place at 1 p.m. If he cycles at 15, then he will arrive at the same place at 11 a.m. At what speed must he cycle to get there at noon? All right. So let's say there is a point A, there is a point B, and this man is going from A to B. If he goes at 10 kilometers per hour, he reaches at 1 p.m. And if he travels at 15 kilometers per hour, then he reaches at 11 a.m. Now the distance between A and B, let's consider that to be small d. This is a constant value. D is constant. So let's say when he goes at 10 kilometers per hour, he took a total of t hours. Because I do not know when he started, so I do not know what the exact time will be. I'm just considering it to be t for the sake of consideration. Now, if he goes from A to B at 15, then he reaches it at 11 a.m., which means he will take a total of t minus 2 hours. Because he reached there 2 hours earlier than 1 p.m. Right. Now, distance being constant, I can say that my first equation will be 10 into t, and my second equation will be 15 into t minus 2. Now, both the distances will be equal. So, you can simply write 10t will be equal to 15t minus 30, or 5t is equal to 30, which means t is equal to 6. So if he travels at 10 kilometers per hour, he will take a total of 6 hours. He will take a total of 6 hours, which means that he must have started at 7 a.m. He must have started at 7 a.m. And if he took a total of 6 hours, then another thing that I can calculate is the total distance, which will simply be equal to 10 multiplied by 6, and that is equal to 60 kilometers. Now what's the question? At what speed must he cycle to get there at noon? Now if he started at 7 a.m. and if he wants to reach his destination at noon, that means he took a total of 5 hours. So total time that he took will simply be equal to 5 hours. Distance is equal to 60 kilometers. So we can simply say that the speed will be equal to 60 divided by 5, and that will be 12 kilometer per hour. So if he wants to get there by noon, then he needs to travel at a speed of 12 kilometers per hour, and that's our final answer. Okay, now let's move on to the next question. Pause the video and draw this one, please. Alright, let's draw this one. A straight road connects point A and B. So we have A, we have B. Car 1 travels from A to B and car 2 travels from B to A, both leaving at the same time. After meeting each other, they take 45 minutes and 20 minutes respectively to complete their journeys. Okay, let's suppose they meet at some point M here. Now, after meeting, A took 45 minutes and B took 20 minutes. Now, if they both started at the same point of time, then I can conclude this one thing. Time taken by car 1 to reach from A to M will be equal to time taken by car 2 to reach from B to M. I'll repeat myself again. If both of them started at the same point of time, then I can conclude that time taken by car 1 to go from A to M will be equal to time taken by car 2 to go from B to M. So if A to M it took T minutes, car 1 took T minutes, then B to M car 2 took T minutes. Okay. And it also says that car 1 travels at a speed of 60 km per hour. So you can simply say that car 1 speed is 60 km per hour. Then the speed of car 2 will be what? Okay. Now, let's consider the scenario of AM, the distance AM. Now, the car 1 took a total time of T minutes and let the speed be S1. Car 2 took a total time of 20 minutes and let its speed be S2. Now AM distance is constant whether you go from A to M, that is for car 1, or whether you go from M to A, that is for car 2. The distance is constant, which means I can write D will be equal to T into S1, which is equal to 20 into S2. Now both the times are given to us in minutes, so I don't have to worry about converting them. Okay, and I'm considering S1 and S2 to be the speeds having the same units, so I don't even have to worry about the units of S1 and S2 also. So D is equal to 2S1 is equal to 20S2, which means from here I can write S1 divided by S2 will be equal to 20 divided by T. This is my first equation. S1 by S2 will be equal to 20 divided by T. The second case that I will think of is BM or MB. Now time taken by this car 1 in going from M to B is 45 minutes. Its speed is again S1 and car 2 took T minutes and its speed is S2. So you can say that 45, you can say D, that is equal to 45 S1, which is equal to T S2. So again from here I can say S1 over S2 will be equal to T by 45. This is my equation number 2. Now S1 and S2 will be equal, of course it's a ratio. So we will have 20 by T will be equal to T by 45, or you will have T square is equal to 900. We will have T square is equal to 900, which means T is equal to 30. Which means both the cars took 30 minutes to reach M. From their respective starting points, they took a total of 30 minutes. Now once we have the value of t, then I guess we can calculate S1 and S2 also. So you can use either of the two equations, whichever one you want to take into consideration. For example, if I took this one, so I can simply write, now S1 is given to me, I believe that, yeah, the speed is 60 kilometers per hour. So 60 divided by S2 will be equal to 20 divided by 30. So S2 will automatically be equal to 90 because the ratio is 2 is to 3. And that's your answer. Alright, let's move on to the next question. Pause the video and try this question, please. Okay. So two persons are walking beside a railway track at respective speed of 2 and 4 km per hour. So we have a railway track. This one person which is going at a speed of 2 km per hour. There's another person which is going at a speed of 4 km per hour. A train came from behind and crossed them in 90 and 100 seconds respectively. Okay, so there is this train. So let's say the speed of the train is S, and this train crossed them in 90 and 100 seconds respectively. Now, if I use the concept of relative speed, if the things are traveling in the same direction, then the relative speed is basically the difference of their speeds, right? So the relative speed of the train with respect to this man A, so speed of train with respect to man A will be equal to S minus 2, and speed of train with respect to this man B or this person B will be equal to S minus 4. Now of course S minus 2 will be greater, so you can say that STA will be greater than STB. So greater the speed, less the time taken to cover the distance. So I can say that time taken to cross this person A will be greater, hence train must have taken, sorry, if the speed is more than time is less, I'm saying the opposite. So the time taken by this train A to cross this, sorry, the time taken by this train to cross this person A will be 90 seconds because the relative speed here is more, and to cross this person B it will be 100 seconds because the relative speed here is less. Now, whenever a train crosses a man or a train crosses a pole, then the time taken by train to cross a man or a pole is usually calculated as length of the train divided by their relative speeds. Time taken by train to cross a man or a pole, because the width of a man or width of a pole is considered to be negligible in comparison to length of the train, right? Usually trains have a length of 500 meters or 700 meters, and a man and a pole will have a width of like what, half a meter or even less than half a meter. So it's not usually taken into consideration unless and otherwise mentioned in the question. So time taken will simply be length of the train divided by the relative speeds. Now let's consider the train having length L. So first equation that I can form is L divided by S minus 2 is equal to 90, and second is L divided by S minus 4 is equal to 100. So your first equation, this is your second equation. When you divide the two equations, then you will get S minus 4 divided by S minus 2 is equal to 9 by 10. You can cross multiply, so 10s minus 40 is equal to 9s minus 18. So you will have s is equal to 22. S is equal to 22. That means the speed of the train is equal to 22 kilometer per hour. Now what's the question? The time in seconds taken by train to cross an electric post. Now again, electric post, the width of the post is negligible. Now before we calculate the length, the time taken by the train to cross that electric post, let's calculate the value of L, that is the length of the train, because that's something that we require. Now if S is equal to 22, then L divided by 22 minus 4, that is 18, will be equal to 100. I'm making use of equation number 2. Okay, I have replaced this S by 22. So L will be equal to 1800. So time taken will simply be equal to length of the train, that is 1800, divided by its speed, that is equal to 22. So that is 900 by 11 seconds. That is 900 by 11 seconds. If you want, you can simplify this further. So that's 8 times, you will get 88, then it will be 20. So 1 times 11, so it will be 81.8181, and so on and so forth. Okay, that's roughly 82 seconds. Okay, now let's move on to the next one. Pause the video and try this question, please. Okay, let's see what we can do with this one. In a car race, car A beats car B by 45 kilometers. Car B beats car C by 50. And car A beats car C by 90 kilometers. The distance in kilometers over which the race has been conducted is. Okay. So let's say this is the starting point, this is the finish point. Car A beats B by 45 kilometers. That means when car A reached here, B must have reached someplace here. Let's consider the entire distance to be D. So this is 45 because car A beats car B by 45. So when car A was on the finish line, car B basically was 45 kilometers behind car A. Now the time in which this car A covered the entire journey, which is D, I can say that car B would have covered a distance of D minus 45 because car B was 45 kilometers behind car A. The time was same. Now if the times are same, then I can say that D divided by speed of A, which is time taken by A to cover the entire distance, should be equal to D minus 45 divided by SB. That is the time taken by car B to cover 45 kilometers less than the entire length race or entire length of the race, basically, whichever way you want to put that up. So D divided by SA, that is time taken by car A to cover the entire distance D, will be equal to D minus 45 by SB, which is the time taken by car B to cover 45 kilometers less than the entire length of the race, which is given to us in the question. So this is my scenario number 1. Now second thing is car B beats car C by 50 kilometers. So again, this is the starting point, this is the finish point. Now car B beats car C by 50 kilometers, so this will become 50. Again, you will use the same concept. We'll again consider the length to be D because it's the same race, so the entire distance has to be the same. So I can say that D divided by SB should be equal to D minus 50 divided by SC. And my third scenario will be, this is start, this is finish. When A finished the race, then C was 90 kilometers behind. So D divided by SA should be equal to D minus 90 divided by SC. Now from the first one, I can make a conclusion that SA divided by SB should be equal to D divided by D minus 45. From second one, I can make a conclusion that SP divided by SC is D divided by D minus 50. And from third one, I can make a conclusion that is SA divided by SC, D divided by D minus 90. Okay, now the distance, we need to calculate the value of D. Okay, now in order to calculate the value of D, what I can do is, this is my equation number 1, my equation number 2, and this is my equation number 3. I can do equation number 1 multiplied by equation number 2 and whole divided by equation number 3. Let's see what will happen. I will have SA by SB multiplied by SB by SC whole divided by SA by SC. Now SB and SB will cancel out. So you will have SA by SC divided by SA by SC. So everything is gonna cancel out on the left hand side, and this will be equal to D divided by D minus 45, D divided by D minus 50, and D divided by D minus 90. So everything cancels out, and this entire expression that you have here will basically be equal to 1. This entire expression that is written in the green box will basically be equal to 1, because everything on the left hand side is getting cancelled out. Now in order to solve this, I'll be rubbing off a couple of things from my screen. So I have 1 which is equal to D square divided by D minus 45 into D minus 50 divided by D divided by D minus 90. You will have 1 is equal to D square into D minus 90 divided by D minus 45 into D minus 50 into D. So D and D cancels out. So you will have D square minus 95D plus, so 50 into 45, 45 is into 5 is basically this is 245 and a 0, and that is basically on the right we will have D into D minus 90. So D square minus 95D plus 2450 is equal to D square minus 90D. So D square cancels out, and 5D is equal to 2450, or D is equal to 5 fours are 20, 45 divided by 5 is 9, so D is equal to 490. So the distance in kilometer over which the race has been conducted is equal to 490 kilometers. I think I've made one silly error. Yeah. Okay, I'm sorry for that. And this is 45 into 50 is 2250. It's not 2450. I've made that error. I'm sorry for that. So this is 2250. So this will basically become 450. But anyways, this is the way how you are supposed to solve the question. Okay. Okay. Got it. All right. Let's move on to the next one. Pause the video and try this question number 14, please. All right. Let's try this one. Question number 14. So there are two friends A and B, and they are basically 1200 meters apart. If A starts moving towards B at a speed of 6 meters per second, so after how much time should B start moving towards A at a speed of 15 meter per second so as to meet exactly at the midpoint of initial distance between them? Okay, so if they want to meet at midpoint, I can say that A will cover 600 meters and B will also cover 600 meters. Let's solve them separately. A is moving at a speed of 6 meters per second, which means time taken by A will be simply equal to 100 seconds. Time taken by A will simply be equal to 100 seconds. Now, this guy who starts from B, or this person B, also needs to reach there after 100 seconds or at 100th second, because they want to reach at the same point of time, right? Now B is traveling at a speed of 15 meter per second, so time taken by B will be equal to 600 by 15. Now 60 by 15 is 4, so that will be equal to 40 seconds. Now B is reaching there after 40 seconds, right? Now that means A and B will definitely not start at the same point of time. Now if B is only taking 40 seconds, which means he needs to wait for 60 seconds. He needs to wait for 60 seconds so that they both reach at the same point of time, considering the fact that A is taking 100 seconds. So B needs to wait for a minute, or you can say 60 seconds, whichever way you want to put this up. 1 minute or 60 seconds. And that's your answer. That's it. Okay. Now let's move on forward. Pause the video and try this question, please. We just did a question like this a couple of minutes ago. So you guys should be able to solve this question. In a 100-meter race, A beats B by 10 meters. Okay, so we have a race and this is 100 meters. A beats B by 10 meters, which means in the time when A will cover 100 meters, B will cover 90 meters. In a time when A will cover 100 meters, B will cover up 90 meters. The time is same. So time will be equal to 100 divided by speed of A, which will also be equal to 90 divided by speed of B. A beats B by 100 meters and B beats C by 10 meters. Sorry, A beats B by 10 meters and B beats C by 10 meters again. So when B will finish the race, at that time C would have covered up only 90 meters. The same concept again. So time taken will be equal to 100 divided by speed of B, which is equal to 90 divided by speed of C. From the first equation, I'll get speed of A divided by speed of B is equal to 10 by 9. From the second one, I will get speed of B divided by speed of C is also equal to 10 by 9. This is equation 1, this is equation 2. Let's multiply the two equation. So speed of A divided by speed of B whole multiplied by speed of B divided by speed of C is equal to 10 by 9 multiplied by 10 by 9, which will give us speed of A divided by speed of C is equal to 100 divided by 81 is equal to 100 divided by 81. This basically means when A will cover up 100 meters, B will cover up 81 meters, right? Because the timings are same. Because the question is by what distance A beat C. That means the question is basically asking when A will cover up the entire 100 meters, when A will cover up the entire 100 meters, C will be where? Now the ratio of the speed is 100 by 81. That basically means when A will cover up 100 meters, C will cover up 81 meters. That's the whole point. So by what distance A beat C? So A will beat C by 19 meters. A will beat C by 19 meters, and that's your answer. Okay, now let's move on. Pause the video and draw this question number 16, please. All right, let's see what we can do with this one. A man travels X% of a certain distance at an average speed of 50 miles an hour. So let's say the total distance is equal to D miles. So this man travels X% at 50 miles an hour. So X% is basically XD by 100. At 50 miles an hour. And travel the remaining distance at an average speed of 70 miles an hour. Now if X% is already being traveled, which means the leftover distance will be 100 minus X%. Which means the leftover distance will be 100 minus X%. So the remaining will be 100 minus X divided by 100 into D, and this is at 70 miles an hour. Find the average speed of the man for the entire journey in terms of X. Now, how do you calculate average speed? This is something we have already discussed while we were discussing the basics of time, speed, and distance. Now, average speed is nothing but total distance divided by total time taken. So, we need the time. So, time taken in the first scenario when he travels X% will be XD by 100 whole divided by 50, and that is equal to XD divided by 5000. Time taken in second scenario, that is for the remaining 100 minus X%, that will be equal to 100 minus X into D divided by 100 divided by 75, and that is equal to 100 minus X into D divided by 7500. So you can say that the average speed is equal to total distance divided by total time, that is XD by 5000 plus 100 minus X into D divided by 7500. Now 5000, 7500, so I think we can take LCM as 15,000. So this is D divided by this is 15,000. So this will become 3XD plus 2 into 100 minus x into d. Okay, so I'll cancel this d first of all. Take this 15,000 to the top, and this will basically become 15,000 divided by 3x minus 2x is x plus 200. So this is the average speed, which is 15,000 divided by x plus 200, and that's basically your final answer. That's it. Correct. Okay, now let's move on to the next one, and next one is basically our data sufficiency question. So this is more related to the students who are preparing for GMAT exam. But anyways, those of you who are preparing for GRE can also have a look at this question, because anyways, the main purpose of making these videos is you guys understand the concept on how to solve a particular question, right? Okay. Pause the video and try this question, please. Okay. At the same time, Sue began rolling a wheelbarrow from X to Y. Nancy started walking along the same road from Y to X. Okay, so I have Y, I have X. So Sue started rolling a wheelbarrow from, okay, so she's going from X to Y. So let me just change this X and Y. So she's rolling something. Okay. Nancy started walking along the same road from Y to X. If Sue's traveling rate was 2 feet per second, so this is okay, 2 feet per second, and Nancy's was 3 feet per second. Okay, so Nancy is 3 feet per second, and the wheelbarrow wheel rolled without slipping. What's the radius of wheel on Sue's wheelbarrow? What's the radius of the wheel on Sue's wheelbarrow? Okay. Now, whenever you have a circular thing and that is basically rotating, considering that the radius is r, so you can basically say that in one revolution, distance covered by the wheelbarrow will be equal to 2 pi r. Distance covered will basically be equal to 2 pi r, that is basically equivalent to the circumference. Okay. Now so what's the question? We need to calculate the radius of the wheel. Okay. Now in one revolution, distance covered by wheelbarrow is 2 pi r, where r is the radius of the wheel. Let's say suppose it covered a total distance of d, then you can say that the d distance will be equal to n into 2 pi r, where n represents the number of revolutions. Where n represents the number of revolutions. So it's going to be number of revolutions multiplied by distance covered in one revolution. Okay. So we need to figure out this value r. Let's see how we can do that. The first statement says at the moment Sue and Nancy cross paths, Sue has traveled 60 feet with the wheelbarrow. Now, if Sue has traveled a total of 60 feet, that means I can say that the distance covered by wheelbarrow will be equal to 60 feet. Now, D is equal to 60, so I can say that from statement number 1. From statement 1, my equation is D being 60, I can say 60 is equal to N into 2 pi R. Now, do I know the number of revolutions the wheelbarrow has made, or basically the wheel has made? No, I don't think I know that. So I don't know the value of n. Now there are two variables in this one equation. So there are like a lot of possibilities one can have. So if I don't know n, I can't calculate r. I need that value. So D, A, B, C, E. A goes out, D goes out. Statement number 2 says the total number of wheel revolutions during Sue's trip from X to Y was 75. So N is equal to 75. Now, simply knowing N will not give me the value of R, because R is also dependent upon the total distance covered. And I don't know that. Now, N is 75, which means, so B is out basically, because simply by knowing N, if I don't know the value of D, I can't calculate R, because R is dependent on both the values. It's dependent on R as well as D. Now, if I use both of them, that is 60 is equal to N into 2 pi R and N is equal to 75, I have the value of D, I have the value of N, which means I can definitely calculate the value of R. Now, I don't need to calculate that. I just need to know in which way I can answer the question. So if I use both these statements, if I combine both these statements, then I can answer the question. Hence, my answer is option number C. Okay. So C is the correct answer that you're basically looking for this question. Simple question. You just have to know the basics. That's it, nothing else. Okay, pause the video and try this question, please. Based on the same concept as question number 17. Alright, let's see what we can do with this one. On Monday, A drives his Ford Escort with 18-inch tires, okay, averaging a miles per hour. Okay, this should be within some sort of a comma, because it's averaging A miles per hour, okay. So Monday, this guy A is traveling his Ford Escort and the radius of the wheel is 18-inch and the speed is A miles an hour. On Tuesday, now it's Tuesday, A switches the tires on his car to 24-inch tires. This is 24-inch. Average speed as same as that on Monday. So we have the same speed, which is again equal to A miles an hour. What is the percentage change from Monday to Tuesday in the average number of revolutions that A's tires make per second? All right. Now we know that distance is basically equal to 2 pi r, that is distance covered in one revolution, which is basically equal to the circumference, multiplied by n, which represents the number of revolutions. So if we talk about speed, we can say that speed will be equal to 2 pi r into n divided by time, which is t. So on Monday, we can say that A will be equal to 2 pi 18 into n1 divided by t1. This is basically for Monday. And for Tuesday, A is equal to 2 pi 24 into n2 divided by t2. Now, since these speeds are equal, we can basically equate two of them. So I will have 2 pi into 18 into n1 divided by t1 is equal to 2 pi 24 into n2 divided by t2. 2 pi goes. So we can say that n1 t2 divided by n2 t1 is basically equal to 24 by 18, which is nothing but 4 by 3. Now, if you read the question carefully, the question is what is the percentage change from Monday to Tuesday in the average number of revolutions that A tires make per second? The question is about per second. It's not about the entire, it's not about the average, it's not about the percentage change in the difference of total number of revolutions. That's not the question. The question is per second, because now here T1 and T2 is also making a difference. We, as of now, we are unable to eliminate T1 and T2. Okay, we are yet to do that. We can't do that because we have no information regarding the time taken. Now, since the question is about per second, so what we'll do is we'll divide the numerator by T2 and denominator by T1, because the question is about per second for individual second. Okay, so for per second you can simply say that n1 divided by n2 will be equal to 4 by 3, or in short you can say that n2 divided by n1 is equal to 3 by 4, which is equal to 1 minus 1 by 4. N2 is the number of revolutions made on Tuesday. N1 is the number of revolutions made on Monday. Now it's 1 minus 1 by 4. Now you are doing 1 minus 1 by 4, which means there is a decrement of 25%. There is a decrement of 25%. Since you are doing 1 minus 1 by 4, so reducing the fraction by 1/4, which is basically 25%. Again, that's basically your answer. Okay, let's move on to the next one. Again, this is a question based on upstream and downstream. So pause the video and try this question. Okay, let's see what we can do with this one. A boat traveled upstream a distance of 90 miles at an average speed of v minus 3 miles per hour, and then traveled the same distance downstream at an average of v plus 3 miles per hour. If the trip upstream took half an hour longer than trip downstream, how many hours did it take for boat to travel the downstream? Okay, so if we consider the case of upstream, time taken in going upstream is equal to distance, which is 90, divided by v minus 3. And if we consider the case of downstream, then it will be td, and that is equal to 90 divided by v plus 3. Now the trip upstream took half an hour longer, so we can say that tu minus td is equal to 1 by 2. So we will have 90 divided by v minus 3 minus 90 divided by v plus 3 is equal to 1 by 2. So you will have 90, 1 divided by v minus 3 minus 1 divided by v plus 3 is equal to 1 by 2. So 90 divided by v plus 3 minus v plus 3 upon v square minus 9 is equal to 1 by 2. So you can cancel the two v's. 3 plus 3 is basically equal to 6. 6 into 9, you can basically say that that's 54. 540 into 2, that's 1080, and that is equal to v square minus 9. So v square is basically equal to 1089. So what's the question basically? We need how many hours did it take for the boat to travel downstream? So you need to calculate this, and you need to calculate the value of t sub d, but for that you need the value of v. Now v is basically under root of 1089, and under root of 1089 is basically equal to square root of 33. So we can simply say that v is equal to 33. Now put that value of v here. So time taken in going downstream is equal to 90 divided by 36. So you can do 10, this is 4, that is 2.5 hours. That's your answer. Okay. All right, so the last question for the video, this is a typically an easy question, so give this one a try. Okay, a hiker walking at a constant rate of 4 miles per hour is passed by a cyclist traveling in the same direction along the same path at a constant rate of 20 miles per hour. Okay, this hiker, this is going at 4 miles an hour, and there is a cyclist and this cyclist is going at 20 miles an hour in the same direction. The cyclist stops to wait for the hiker 5 minutes after passing her. While the hiker continues to walk at her constant rate, how many minutes must the cyclist wait until the hiker catches up? Okay. Now, the cyclist stops to wait for the hiker 5 minutes after passing her. Now, what would have happened in those 5 minutes? In 5 minutes, this hiker would have traveled a distance of 4 into 5 by 60. So that is 1 by 3 kilometer. And the cyclist would have covered a distance of 20 into 5 by 60. So that is 5 by 3 kilometers. Right? Now the cyclist stopped. So we can basically say the difference in the distance covered is basically 5 by 3 minus 1 by 3, which is 4 by 3 kilometers. So which basically means this cyclist is 4 by 3 kilometers ahead of the hiker. The cyclist is 4 by 3 kilometers ahead of the hiker. Now, how many minutes must the cyclist wait until the hiker catches up? Now, hiker is traveling at a rate of 4 miles an hour. And the cyclist is 4 by 3 miles ahead of the cyclist. So, time after which the hiker will catch the cyclist will be equal to 4 by 3 divided by 4. So, that is basically 1 by 3 hours. So, 1 by 3 into 60, and that is simply equal to 20 minutes. That is simply equal to 20 minutes. That's it. So this is all as far as time, speed and distance is concerned, guys. We have done the basics, we have done the questions. There is, as far as conceptually, and let me very frank, as far as questions are also concerned, if you have gone through these couple of videos, these 3-4 videos that I've made, this is like more than sufficient for you to cover up your TSD for either for GRE or for GMAT exam, right? This is actually more than sufficient. Okay, so thank you so much, guys, for watching the video. Please do like the video, share it with your friends, with your folks, whoever is preparing for GRE and GMAT, so that they understand how to prepare for it, what are the basics that they need to learn and know so that they can ace the exam, right? And please do subscribe to the channel. And if you have any questions, if you have any concerns, if you're looking for preparation for any of the exams, do let us know. You can mail us, you can WhatsApp us. Okay, so thank you so much. Keep watching and keep learning, guys. Thank you so much once again.